Okay, great. Thank you, Rob. All right, we are going to just go through some important points that Geert did on his live presentation, because if we found it complex, I think everybody's going to have found it complex. The question is, how is it relevant to the general public? I think that's the most important point. He said a lot of things that were very important, but a lot of people just want to understand what is it that's relevant to them. So I'm just going to bring up on screen here now, Rob, his slides that he shared with me. Okay.
Yeah.
So this one was talking about, I'll just roll through them and then we can go back through them one after the other. So this one was talking about the fact about the conserved sequences in all coronaviruses. This is all of them here, and these sequences on the S2 fusion peptide. And I think this is the N-terminal domain. So he's talking about, we'll come back to that. Then this is where he's talking about steric immune refocusing, which I think is very, very important for us to try and see if we can piece together. Then this one here is where he's talking about low affinity antibodies stabilizing the viral complexes. This one here is talking about the viral immune escape. BTI meaning BTI?
Breakthrough infection.
Breakthrough infection. That's right. Yeah. So yes, viral
BTI is
yes, viral breakthrough infection.
No, vaccine
breakthrough infection. Yes, that's right. Good. We'll come back to that.
And by the way, Philip, that slide you just had up is the most important slide.
Yes, this is the one that Geert was most focused on as well, and so we're going to go through this one as well. Then we had this one with regards to the avidity over time and this neutralization decrease over time. And then this is the cycle of variants and the non-neutralizing antibodies, vaccine breakthrough infections cycle that happens. This I think was important. We didn't talk about this in the live, but this was talking specifically looking at the response with regards to the JN1 versus the BA.2.6. I wish I knew exactly which paper this came from, but looking at the different neutralization titers on it, and I think that this is really what has gotten Geert very worried, and so trying to make sense of this, I think, is very important. And then the final slide was, well, this one was the dog with the bone. I think this one is pretty straightforward. So that's the essence of it, Rob. And so what I want to try and make sure that I've got, and I've also got his paper, the paper that he produced, which was about the fulminant spread of JN1 worrisome prognostic indicator. And I'd highlighted a few things where he was talking about the cross-variant reactive spike antibodies and so on. So this was an important one that I was going through to try and get my head together. Before I start asking your thoughts on it, I thought it's important to bring this up as well. So I'll just make this big screen. So this was the paper about neutralization escape, the BA.2.86, which is the precursor to the JN1. And so it's a very important piece of relevant information. Now, what I thought was very important for the public to understand is this bit about the spike protein, because it nicely shows it. And so this here, spike protein here, this is 180 degrees rotated. The N-terminal domain, which Geert kept on making reference to, is that purple section. Purple. This is the 180 degree purple. This is the top section. So this N-terminal domain is all the way here. And then the receptor binding domain is all of the other colors. And down at the bottom here would be the S2 protein. So you have the S1 and S2. And this is then showing all of the variations of the BA.2.6 from the BA2. So it shows you how varied, how many changes occurred in this viral selection, which I guess is where the immune pressure comes from. And so it's showing you even from all the different angles that you can have about this spike protein making changes because of immune pressure. So this is what I think is quite important to try and see if we can put some things together. There are some very important things that Geert had highlighted that I really want to try and get my head around. And the other one is about this cross-reactive cytotoxic T lymphocyte. So this is where he has it here. As he says, the alarming observation is that the JN1 is now outpacing other co-circulating variants. This rapid dominance is attributed to mutations in viral proteins extending beyond the S protein. Now, this is the bit extending beyond the S protein and accounting for a growing number of SARS-CoV-2 variants globally. The dominant propagation of JN1 suggests that the population's immune response does no longer primarily consist of broad cross-variant reactive antibodies, but of newly emerging immune effectors that are no longer spike-specific, but still exert pressure on viral infectiveness. And this is where he thinks that there is this immune refocusing, which has shifted from the cross-variant reactive antibodies to SC2 reactive cytotoxic T lymphocytes. Now, when we look at that, where do you think that the public needs to first understand why Geert is so worried? Where would you start?
Yeah. Let me explain what I think is the bottom line in his message. I think the most important thing to understand are the virulence inhibiting PNNABs.
All right. So before you go, so when you say PNNABs, so spell that out.
Okay, those are polyreactive non-neutralizing antibodies.
So this is a broad antibody, part of our innate immune system.
No.
Okay.
These are antibodies that are produced when the neutralizing antibodies that were originally produced against the spike protein cease to be effective. They lose their capacity for neutralization.
And so then we have the
Yeah, so remember we had the initial Wuhan strain.
Yes.
And then the vaccination triggered neutralizing antibodies against that Wuhan strain. But then fairly soon, new variants developed that were resistant to those antibodies. So the neutralizing capacity of those neutralizing antibodies, the original ones, markedly diminished. When that happens, the immune system then, to kind of compensate, produces polyreactive non-neutralizing antibodies, the PNNABs. And those are broadly reactive, but not real strongly neutralizing, partially neutralizing. So they're beneficial. They're relatively short-lived. So they aren't as good as the original neutralizing antibodies that would match whatever variant is circulating, but they're helpful. But there's two things to know about the PNNABs. And again, this is all according to Geert's analysis. One thing is that those PNNABs, paradoxically, have an infection enhancing capacity. So
Okay.
when those PNNABs...
Yeah, so that's an important point there. And I think that that's something that people need to understand, because when they say that bit, I remember when Geert said it, and that stuck with me here. And I'm going to show you something that I think helps to explain that. When these antibodies bind to different parts of the spike protein, so a lot of people don't realize that this receptor binding domain here has three different positions. It can be in fully open one up, one down, two up, one down. So it's like a, what's a good description? It flips in and out of different positions,
Right.
and it
Open,
does that,
open and close position.
open and close positions, and that it does that to evade the immune system. But it means that when it's closed, it can't bind to ACE2. What
Well,
I think Geert was saying was that when some of these polyreactive antibodies bind to the spike protein, they then lock this in an open position.
yes, those PNNABs that we've been talking about are directed against the N-terminal domain rather than the receptor binding domain.
Yeah, so they are focused on here, but they lock this in an open position so that it actually makes it easier for the virus to bind to ACE2, which
Yes.
is mhm.
So that's what we mean by infection enhancing effect of the PNNABs. Now, more important than that, though, and more relevant to what's going on right now, is that those same PNNABs have a virulence inhibiting effect. And the story there is, and again, this is according to Geert's analysis, dendritic cells, which are antigen presenting cells, very important cells that kind of patrol the body and look for threats, viruses, for example. The dendritic cells are capable of attaching to the virus, kind of absorbing the virus onto their tentacles. And so virus can become attached to the dendritic cells, and these dendritic cells migrate throughout the body. So there are dendritic cells in the upper respiratory tract. They absorb the virus onto their tentacles. They migrate down potentially to the lower respiratory tract, where if the virus is released from the dendritic cells in the lower respiratory tract, that virus can then infect the epithelial cells in the lungs and trigger a massive inflammatory reaction in the lungs. So we don't want the virus to get unleashed, released from dendritic cells into the lower respiratory tract. The PNNABs have a very beneficial protective effect. They have the ability to attach to the virus or the virions that are tethered to the dendritic cells. And so when you have the PNNAB attached to the virus that's attached or tethered to the dendritic cells, then when the dendritic cell migrates down to the lower respiratory tract, those PNNABs prevent the virus from being released, and they don't get into the lower respiratory tract to infect epithelial cells or trigger massive inflammation. So probably the most important bottom line, one of the most important bottom lines for the public to understand is that vaccinated individuals have had fairly high levels of virulence inhibiting PNNABs, which are also infection enhancing. But the most important of those two effects of the PNNABs is that they are virulence inhibiting. So if for some reason, and I'll explain what those reasons are, if those titers of virulence inhibiting PNNABs drop below a certain level, below a certain critical level, then the vaccinated individuals will no longer have that virulence inhibiting effect of PNNABs.
Rob, I'm going to pause you here a minute. So while you were talking, I started to build a slide. I'm going to show you what I'm doing here. So this is BioRender. I use that to build my slide. So I've got here a dendritic cell. And this is just to help me and everybody else get some of these points. So this is the dendritic cell.
Yeah.
This here is the virus.
Yeah.
And we are saying that these polyreactive antibodies here,
Yep.
sorry, let me see if I can get it. These polyreactive antibodies floating around have bound to the virus, and they also help the dendritic cell to hold on to the viral particles.
Well, the virus is actually tethered to one of those arms of the dendritic cell. Yeah.
Because
Like that.
of these polyreactive um,
Well,
um,
no, it not necessarily because of those polyreactive. They would do that in the absence of those PNNABs. So the first thing that happens is that those, in the context of an inflamed state,
yeah.
those viruses become tethered to the arms of the dendritic cell, and then the PNNABs attach to the virus that is tethered to those arms.
Yeah, that's an important point. So going back to this image here then, so in effect now, I've just put this virus tethered, and so now we have these PNNABs floating around,
Yeah,
and they then, so when they attach to the viral particle,
yeah. That makes it difficult for that viral particle to get released from the dendritic cell when the dendritic cell migrates down to the lower respiratory tract. So, the virulence inhibiting PNNABs are protective because they prevent or minimize the release of virus that has been tethered to the dendritic cell, prevents those viral particles from being released from the dendritic
Mhm.
cells.
Now, why would the dendritic cell want to release these viral particles in the lower respiratory tract?
Well, that's a pretty deep question, and I'm not sure I can answer that. I it I can only speculate. It's possible that two things happen when the virus gets released in the lower respiratory tract. One is a bad thing, that the virus can infect cells, and of course that would not be good. But the other thing those viruses do is they may provoke an appropriate immune reaction within the lower respiratory tract. Antigen presenting cells that are located there, localized antigen presenting cells, could pick up those released virions, and that could stimulate or trigger an appropriate immune response, and that could then mitigate the damage of the virus actually getting into cells and infecting those cells. And it could be that this is a way that the immune system trains local parts of
Mhm.
the immune system to handle viruses in case they get into the lower respiratory tract. I'm just imagining that
Yeah,
is
understand. Okay,
there
so
must be some purpose in having dendritic cells migrate down into the lower respiratory tract. Remember, dendritic cells are essentially antigen presenting cells.
yes, yeah,
Normally, the virus gets ingested by the dendritic cell, and then the dendritic cell processes it, puts appropriate
that's right. The major
parts of it on its
histocompatibility
surface, and
molecules on the
presents it to
surface.
the rest of the immune system.
Yeah.
But in the context of considerable inflammation, uh, the virus can just get tethered to the arms of the dendritic cell instead of getting into the dendritic cell. And that's what's going on in the COVID situation.
Now, I'm going to take you back to a paper that I had shown Gert as well. And this paper was looking at what the baseline is with regards to someone who didn't have a booster versus somebody who did.
Mm-hmm.
And so this is showing, and I've got it. So this one here, the person got a bivalent booster. This is at baseline. This is if they had no infection in 6 months, and this is if they had an infection in 6 months.
Yeah.
So I've got it zoned in, so made it bigger here. So what this shows you, so this is a log scale, and this is a neutralization antibody titer. And what I was saying to people, this is the Wuhan virus, BA1, 2, 5, XBB1, 1, 6, all the way down to BA2, 6, which is the closest to JN1. All of these antibodies here, this is 16,000 versus 300.
Mm-hmm.
These are representative of the vaccine-induced antibody response that are primarily targeting the N-terminal domain of the spike.
Well, the receptor binding domain.
Receptor binding domain. What percentage do you think would be targeting the N-terminal domain? Do we have any idea?
That I don't know. I don't know that anybody has actually measured titers of the PNNs. Yeah.
But most of these antibodies are therefore, depending on which infection you have, are not going to be particularly useful.
That's right. This whole slide, I think, is not quite as relevant as the other things that we're going to discuss. What it does do, though, is it explains that when a vaccinated person gets a booster, for example, or if they get an actual infection with one of the Omicron variants, the main message of that slide is that they boost up those original Wuhan strain relevant antibodies to the greatest extent, and they don't really produce nearly as much of the newer, more relevant antibodies. But the other thing that's important that slide brings up is that where we are in the stage of the pandemic, and I can show you later what stage we're in. We're in the stage where the CTLs are the predominant immune response that's going on now. That is associated with a decreased ability across the board of B cells to be stimulated to produce antibodies, that even the antibodies to the original Wuhan strain that are have been obsolete for a long time, even those won't be produced in as large a quantity as they once were. And that's even more true of the more recent antibodies. And that includes the PNNABs. These are antibodies that of course, depend on B cells to be produced. And so we're at a stage of the pandemic where the immunologic reactions going on now in response to the virus is dominated by these non-specific cytolytic T cells. So it's a cell-driven response, and no longer an antibody-driven response.
Okay.
And we're at a stage now where the immune system, even if it wanted to, cannot produce the levels of antibodies, even appropriate, relevant antibodies at this stage of the game. But the most important thing is that this means that the immune system can no longer produce the virulence inhibiting PNNABs like it used to. And that's what really concerns Geert, is that the virulence inhibiting PNNABs throughout the Omicron era have been protecting vaccinated people from severe disease and death. And now we're at a stage of the pandemic where the vaccinated people are no longer able to maintain high enough levels of virulence inhibiting PNNABs to protect them from getting infected in the lower respiratory tract. And then very
So
quickly.
just before you go on to that, I'm trying to see if I can capture that in the context of an image. And so I have got here, if I do this. So this is me showing. So this is representative of the plasma cell. It's producing all of these antibodies, these polyreactive antibodies. Sorry,
Mhm.
for some reason I can't move it. And so this is what, even though they've been non-specific, they have been helping to reduce the virulence of the infection. Okay.
Yes, and that's what
Now,
has
Mhm.
that, very quickly. That is what has given the false impression that the pandemic has been subsiding substantially and is going away and is heading into endemicity and is nothing to worry about anymore. These virulence inhibiting PNNABs are what has been giving that false impression that things are not as bad
yeah.
as you would think.
And just to remind, just in case anybody is looking at it, this here is showing these PNNABs, then preventing the virus being properly disposed of in the dendritic cells. And so this is where it's almost hitting.
Released by the dendritic cells.
That's right. So then I've created this slide here, and this now shows the T cells. And so now these T cells are dominating, and this is fading into the background. We no longer have any significant antibodies, but we're shifting now to primarily a T cell mediated immune response. This is almost like what happens in TB.
Well, Geert carefully uses the word cytotoxic T lymphocytes or
Yeah,
CTLs,
yeah,
and he's talking about MHC class 1 unrestricted CTLs. He's not talking, I don't think he's talking about antigen specific MHC class 1 restricted CD8 positive cytotoxic T cells that are generated in a normal situation when we're fighting off a specific virus.
right. So just to be clear for somebody, what you are saying then is that there is a cohort of the immune cells that's similar to antibodies that are broadly reactive. These T cells also are broadly reactive. They're not yet zoned in to being very, very
Yeah.
specific.
And they're not NK cells, which are also cytotoxic
Yes.
cells, but they're not the antigen specific cytolytic T cells. They're sort of in between.
Hmm.
And again, a bit of my own speculation. I think the immune system has tricks it can use in desperation. And I think one of those tricks that it's able to use is to mobilize, activate these relatively non-specific CTLs
Yeah.
to come to our rescue, and they are able to kill virus-infected cells. But in the process of the activation of those CTLs, one of the things that's sacrificed is the
Is the
ability
antibody. Yeah.
of antigen presenting cells to stimulate the B cells to produce specific antibodies. So with the rise of this CTL response, this desperate effort on the part of the immune system to protect the vaccinee with its CTLs, linked to that rise is an inability to keep generating high enough levels of virulence inhibiting PNNABs. So that's where we are in the pandemic.
Hmm.
And that's what Geert is so afraid of at the moment, because another consequence of the dropping levels of virulence inhibiting PNNABs into a suboptimal range, it would be one thing if they were in an optimal range. But when they drop into a suboptimal range, at a population level, that promotes the natural selection and dominant propagation of mutations that enable a variant to bypass that PNNAB virulence inhibiting effect, even if there were high levels of those PNNABs. So if you go back to that drawing that you created,
Yeah.
With the PNNABs attached to the tethered virions on the dendritic cells,
Mm-hmm.
what Geert is afraid is going to happen, and I think he's right, is that a mutation will come along that enables a variant to prevent those virulence inhibiting PNNABs from attaching to the virions on the dendritic cell. And so even if an individual were able to produce what used to be effective levels of PNNABs, those PNNABs will no longer be able to attach to the virus that's tethered to the dendritic cell. So the next drawing that you could make would be
It's almost, I'm making it's almost like a bubble around it, that it's almost suddenly
you just move the antibody off of the virus so that it's just floating around near the virus, but is not really attached to it.
Okay, yeah, I see what you mean. Let me just see if this is not working with that. So I see what you mean. Let me just get some antibodies. Actually, what I'll do
That one down.
is I'll copy that. I'll add a new slide. I'm just capturing these ideas while I can, and then I will use this one here. Let me capture this here, and so now what we have is these antibodies are here, but they can't touch the virus.
Yeah, and that virus in turn is tethered to the dendritic cell.
And so now, okay, so
now if a variant comes along that has a mutation that enables it to prevent virulence inhibiting PNNABs from attaching to those tethered virions, then that variant is going to evade that virulence inhibiting effect. There won't be a virulence inhibiting effect in that instance.
And so now, when it releases the virus that's tethered, it can then infect a cell.
That's right, because you see, there's no antibody glommed onto that virion. So now, because you don't have virulence inhibiting antibodies attached to those virions, that virus can leave the dendritic cell, get into the lower respiratory tract, and create havoc. So one of the two most important messages I think Geert is giving is reminding people that vaccinated people have had less severe disease during the Omicron era because of virulence inhibiting PNNABs, but those levels of PNNABs are dropping and have been dropping recently. And they've dropped into a suboptimal range, and that's not good for two reasons. They're suboptimal, meaning that they can't protect as well as if they were in optimal range. But the second thing is, anytime you have a suboptimal antibody, it makes it easier for the natural selection and dominant propagation of a variant that can overcome that suboptimal pressure to occur. So the second thing that's going to happen, it hasn't happened yet, but it's about to happen, is that in addition to those P and NAB levels dropping to become less and less effective,
yes,
the virus is in the meantime developing an ability, or will develop an ability, to evade that protective mechanism altogether, even if you have some of those PNNABs hanging around.
And so my other slide now, which is showing this here, I've now shown the dendritic cell releasing the virus now going to infect lung epithelial cell.
Yes. And of course, once it infects that lung epithelial cells, that is going to trigger a local inflammatory reaction where the immune system in that location revs up. And then, in addition to getting infection of those epithelial cells, you get a huge inflammatory reaction, which you want, because that's what will kill the virus and keep it from spreading even further. But that's why you get lots of inflammation on the CT scan of the lungs, for example. So now getting to the JN.1 variant, Geert in his analysis points out that the JN.1 variant does not appear as though it's become more virulent itself compared to predecessors.
Yeah.
But it possesses a mutations that are quite different from the mutations that we've been seeing in the other the preceding Omicron variants. And in the beginning, there were mutations in the receptor binding domain. Then there were mutations in the subdominant regions of the spike protein.
Yes.
And now that the JN.1 variant has mutations that aren't even involving the spike protein and are on other proteins of the virus.
Oh, that's an important point. Yes, no, that is critical. So it is no longer ending up with pressure on just the spike protein, but on other parts of the virus.
But the bottom line point of that is when Geert saw that, he interprets that as evidence that the virus is responding to the immune pressure that the CTLs have been putting on the virus. So the virus, his interpretation of that new mutation in the JN.1 variant is that it's evidence that we have arrived at a stage of the pandemic where the CTLs are the predominant immune reaction going on. And the importance of that, as I've already mentioned, is that when the CTLs become the predominant protective mechanism, that ultimately results in the antibodies not being major players anymore.
Okay, now let me show you something
even maintain levels of antibodies anyway.
So this is now important. So this is the structure of the virus. And we have here, this is a normal viral particle. It's cut in half here. Now, what he's saying is that normally, so far, all of the variations have been on the spike protein. But the JN.1 is now having changes no longer just to the spike protein, but to potentially the membrane protein, the envelope protein, the nuclear capsid protein, where it's beyond the spike.
Yeah.
So those epitopes that we normally would be able to use to control any virus? Because that has implications even for the unvaccinated.
Well, or another way of stating it, Philip, is that initially the immune system produced antibodies against the variable part of the receptor binding domain of the spike protein, because that's the most efficient way to neutralize a virus, because that prevents it from getting into cells. Then it started producing the PNNABs, which are directed at more conserved parts of the spike protein. And then we started seeing what Geert refers to as the steric immune refocusing process, which was a process that resulted in the immune system producing antibodies to more and more and more conserved epitopes on the spike protein. Yes, that slide. And so now the immune system is producing antibodies to more conserved epitopes, less immunogenic epitopes. And then the next step is you showed a slide earlier about the universal peptide. Yeah. And now it looks like the JN.1 variant has a mutation in the universal peptide. So we've gone from the variable portion of the spike protein to the more conserved portion of the spike protein. And now we've got a mutation involving the universal peptide. And the important
is this on the spike? This is on the N-terminal domain, is it?
I'm not sure where it is. I
Okay.
don't know enough about that.
Yeah. I got the impression he kept on saying the N-terminal domain. So I suspect that if I go back to my my original image here, what he's saying is that you're starting to get changes in this very conserved part, which is present on almost all coronaviruses, and that we're starting to see changes here. That
well, and I think the universal peptides or epitopes is a step beyond just the conserved epitopes. There's more variability in the conserved epitopes. But the bottom line in Geert's mind, I think, is that when he saw this mutation in the JN.1 variant, he interprets that as an effort on the part of the virus. His interpretation is that the virus has figured out that it needs to move away from evading those other antibodies we've been talking about, and it needs to develop a new trick. And that's when I think he mentions it's possible that sooner or later a mutation is going to develop that expedites viral replication within an infected cell.
And so this is primarily because the virus is now trying to evade cytotoxic, the CTL.
Yes.
No longer is it worried. Yes. So it has the immune pressure is now coming from the T lymphocytes.
CTLs, and no longer coming from the antibodies that have been produced throughout the pandemic.
And so when he shows this slide here, this is demonstrating that whilst these polyreactive antibodies are high, we're still getting some neutralization or pseudo-neutralization. But as the level falls, we're still having infection mitigation here. But below this, you no longer have infection mitigation. And now you're having the virus now with the immune pressure from the cytotoxic lymphocytes, CTLs,
Yeah.
now changing other aspects of the virus to make it evade the immune system.
Yeah. Now, what Geert has realized is that this pandemic has been a dynamic, changing process. The interplay between the immune system and the virus has been constantly changing. And if you go back to that slide,
Mm-hmm.
in the beginning, under A there, uh, long ago in this pandemic, the immune system was producing neutralizing antibodies that neutralized individual virions. And so when the Wuhan strain first came along, we were able to produce neutralizing antibodies that worked as shown in A. But then, thanks to the mass vaccination campaign and the way it promotes variants, the development of the natural selection and dominant propagation of variants, we quickly got variants that were no longer affected or not adequately affected by those initial neutralizing antibodies. So those in B, you see that those neutralizing antibodies are farther away from the virus. They don't have
That's
as
right. Yeah.
strong affinity for the virus. And B that's kind of representative of the PNNABs that are broadly neutralizing, but fairly weakly neutralizing. That's what's shown in B. Then, as those PNNABs and the antibodies spawned by the steric immune refocusing process continues, then the antibodies are are only able to neutralize the virus when the virus is in an aggregate state, as shown in C.
Mm-hmm.
And then as the pandemic goes along, eventually you end up with these large, as the antibodies become less and less effective and have lower and lower affinity, the only way they can try to neutralize the virus is to neutralize it, neutralize these large aggregates, or try to neutralize the virus in these large aggregates. Now, those large aggregates, particularly shown in D, those are taken up by antigen presenting cells and in turn stimulate the production of these CTLs. So you end up in D at that phase or stage of the pandemic. The main thing that is going on in this interplay between the virus and the immune system is these large aggregates are stimulating or activating the CTL mechanism.
CTLs.
Yeah.
So now what I want you to do is just to help me to, let's now try and break it down in a way that almost anybody can understand. And as I was listening to you, the thing that people understand is when you talk, I think, about war, because this is what immunity does. It's fighting a war. We have the Army, we have the Navy, we have the Air Force. When we think of it in that way, the equivalent, I'm just now trying to, is that we had been using the Navy and the Air Force to hit the enemy targets with distance antibodies. They were firing weapons and so on to take out the opposition. The opposition, however, entrenched themselves so that the bombs were no longer effective. So then what happens is that they said, okay, we now need to send in our cytotoxic lymphocytes, which are now the equivalent of the Marines. They are going in on the ground to try and root this out. But in order to do that, you can't still be firing. So it has to shut off your long range weapons because they would kill your I'm just saying in the context. So in effect, you are only now using your cytotoxic lymphocytes to try and fight this war. But as you are now bringing those soldiers in, the enemy is starting to adjust its strategy for the fact that you're bringing this army in on the ground,
Mhm.
and they are now using guerrilla warfare. That guerrilla warfare can then not only overwhelm the army on the ground, but also put the whole country beyond that risk. Is that making any sense?
Um, sort of. I'm
Sort
not.
of. Any better idea?
Um, well, uh, I think an important concept is that once you get to stage D of the pandemic, where you have this
Cytotoxic.
massive activation of the CTLs,
Yeah.
um, and along with it, a massive activation of the APCs,
Hmm.
particularly if those APCs are now having to deal with the universal peptide that is recognizing. Those APCs become very preoccupied with dealing with that situation. And they become less able to help our B cells produce the other antibodies that we've been talking about.
Yes.
And that's why those levels continue to drop.
And so it's leading to technically an immune failure. Is this the last throw of the dice for the immune system?
Well, Geert emphasizes that the remaining tool that highly vaccinated people have had to protect them during the Omicron era is the virulence inhibiting PNNABs. And because we haven't mentioned that, unfortunately, highly vaccinated people's innate immune system has been sidelined. So they don't have their innate immune system, they don't have their NK cells available and trained to help in this war. And as we've already been emphasizing, the antibody approach to fighting this war has become less and less and less effective, and has led to the point where the CTLs need to take over. So one of Geert's major messages is that the one remaining tool that has been protecting highly vaccinated people, namely the virulence inhibiting PNNABs, is now ceasing to be an available tool for them. The levels are dropping.
So
And
they have run out of artillery in the Russia-Ukraine war.
That's right. But I think it's important to emphasize that not only are the levels of PNNABs reducing, but also we are on the verge of a variant coming along that is able to evade that virulence inhibiting effect, even if we still had virulence inhibiting PNNABs around. So for those two reasons, that tool is going to become obsolete, unavailable.
Why is it therefore not going to affect the unvaccinated?
Well, because the unvaccinated people all along have been able to rely heavily on their innate immune system, particularly on the NK cells.
Yeah.
And one of the marvelous things about the innate immune system is that those NK cells actually can learn through and be trained to become increasingly effective, so that each time you're infected with one of the Omicron variants, those NK cells actually get more competent.
Yeah.
They get trained. It's kind of an epigenetic training of those NK cells. And so by now, unvaccinated people living through this Omicron era, they've had lots of exposure to many of the different variants, and each time they get and some of those exposures result in asymptomatic infection, others mild infection, hardly ever any severe infection, at least in young, healthy, unvaccinated. So each time they get exposed to one of these variants, their innate immune systems, specifically their NK cells, become further trained, further competent, better able to fight off the next variant that comes along. And so Geert has emphasized that even this JN.1 variant, or an immediate successor that is more virulent even, he thinks the healthy unvaccinated people, because of their well-trained and practiced innate immunity, particularly their NK cells, will be able to handle these new worrisome variants that will be very worrisome for the highly vaccinated.
Yeah. So here is the only caution that I have, and this is one of the points that I slightly disagreed with Geert on. And I have been trying to emphasize to the unvaccinated is don't get too cocky, because this is not over. I've found when I listen to comments, people are getting a little bit cocky, like, I'm not worried. And I'm thinking to myself, it's not that straightforward, because with each infection, there is damage to the system. Now, as I said, it's not that you cannot get a cold if you've had a cold. And so if you have anything that impacts your immunity, if you are stressed, if you're very tired, and you're in an environment where you're exposed, you can still get infected, because it's just about at that particular time your viral threshold. That's one part. So you won't get severe disease. But this is more complex now than just severe disease. This virus is able to do some damage, even with mild infection. That really is concerning. When you look at the outcomes for reinfections, it's frightening. Now, part of that is that it's part of the highly vaccinated community. The other issue that I'm worried about is the fact that many patients are now carrying co-infections. So it's not just SARS-CoV-2. They have RSV, they have influenza, they now have mycoplasma. It is far more complex. So in a sense, we're in the situation now, which I had feared, where the vaccinated are a risk to the unvaccinated, because it is bigger than just COVID. This is now broad, because you have to now think about it. We are starting to see, because that immune system in the vaccinated is now failing, we're seeing a resurgence in TB. You don't want to be exposed to TB. Do you see what I mean? This is now very, very complicated, and it carries risks for everybody.
Yeah, I think I don't want to speak for Geert, but I suspect the comment he would make is that we're at a stage in the pandemic where stage D of that graph, where the CTLs are the predominant immune phenomenon going on now, immune reaction. And those CTLs are pretty good at protecting, but we've talked about the unsustainability of that. But those CTLs may also be helping the highly vaccinated people to handle those other infections that you mentioned.
Well, one of the problems is that, again, this is what I'm saying, is that I'm looking at it from a very broad perspective. And one of the things that we're seeing, that I can't tell the amount of patients I'm seeing now. I never used to see a fungal infection before. I'm now starting to see fungal infections. So one of the other things that this virus is able to do is wipe out lymphocytes, separate and apart from anything else. It infects them and deactivates them. And this is part of the lymphopenia that we used to see in severe COVID-19. So what we're seeing in the vaccinated cohort is, even if they are trying to mount a CTL response, if they have got viral dissemination, it's taking out the lymphocytes, separate and apart from just the infection. It is a frightening scenario, and I suspect that what we are seeing is now, Geert may be right, now that I reflect on it, is the last throw of the dice. The gasping man is what the body does when it's in a dangerous situation, irreversible shock. It then starts to do unusual things. And yeah, this is pretty serious stuff. It won't, as I always say, clinically, nothing affects everybody, but you have a situation where I can see the cohorts that are going to be first affected. And that is pretty serious. So now I think that I can't think of a better way of explaining it other than the army. I just need, because people understand that Army, Navy, on the ground. I consider the CTLs to be the Marines. You bring them in; they are very specific. They're really good. But if you have a situation where, when you bring in the Marines then allow your opponent to understand the weakness and overcome the Marines, then you've lost the war, because you no longer have artillery. You've run out of artillery. You can't touch them anymore because they are in their bunkers. And now your ground troops, your last throw of the dice, is unable to eradicate the infection. Then they're going to overwhelm you.
Yeah. Well, that's where Geert thinks we are in the pandemic. This has been a dynamic, evolving, changing pandemic process that's had 4 different phases to it, as he's shown on that one graph. And in the early phases, antibodies were the most important thing. And the remaining antibody that is important has been the virulence inhibiting PNNABs. But those levels are dropping, and irreversibly dropping, for the complex reasons we've talked about. And so they will no longer be protective for the highly vaccinated. And then on top of that, the suboptimal levels of those virulence inhibiting PNNABs will promote the natural selection and dominant propagation of variants that are able to overcome any of the PNNABs that are still trying to help people out. And that's where we are. And that's how he interprets the JN.1 variant. He's saying that's evidence that we're at that CTL phase of the pandemic. And that CTL phase is associated with an inability to continue to produce
antibody. Yes, when I think about it from an army perspective, it makes sense. If you're sending your troops in, you can't afford to use the long-range weapons because you don't know who you're going to hurt. That's how I'd make that analogy.
Well, it's not so much that you can't afford to do them or that you're purposely shutting them off. You're unable to use
You're
them.
unable to do it. Yes. Wow. So that's very, very helpful, Rob, and I'm going to then try and see if I can piece it together this evening and try and take those concepts, because a lot of people couldn't quite piece everything together. Even I, as I said, but granted, I was a bit distracted making sure all the comments were going in, so I couldn't focus all my attention on Geert. But I knew it was important to let him explain.
I hope I've done justice to what Geert has been.
No, I think that this is why I knew to reach out to you, because it's one of those that, as I said, I think that this discussion is valuable for people as well. So I'll put it on my Substack, so people can see us thinking it through and working it through and trying to come up with a clear explanation for it. And it may require another meeting between the three of us to discuss this in some more detail. I think that would be very helpful. But I did think that recent interview, to just let Geert express all those ideas, was
Yeah.
extremely important.
The other thing I would mention, Philip, is I don't know if you've read that article I wrote about, it's entitled "In Anticipation of a Highly
No,
Virulent
I'll take a look at
Variant."
it.
And because the logical question that the public is going to ask is, okay, you're telling us that a catastrophe is about to unfold, but you're not telling us what we can do about it.
Yes.
And I think that's the next important thing, that the public and the physicians who are taking care of the public, they need to start thinking about, okay, if Geert is
What do we
right,
do?
and I think he is
Yeah,
right.
do you mind if I use that as well? I think I'll make reference to it. And where is it? I have it, but do you have it on your site?
It's on my website.
What I'll do is I'll lead people to the Substack and then lead people there. Or no, actually, I'll put some of it in the description on YouTube.
Yeah.
So yeah.
And then also, I wrote, I think I sent it to you yesterday, an open letter to physicians and physician organizations, which capsulizes what we've been talking about this morning. It explains the PNNABs and what's happening. And then it's urging physicians and physician organizations to please alert the public about Geert's concerns so that they can prepare.
Yeah, excellent. I will go through that. So great. Thank you very much, Rob. Wish me luck to explain these concepts, and have a great evening.
Okay, you too.
Okay. All right. Bye.
Bye.